Hi, Eric. I just wanted to go through your problem. I think there was some confusion about how to calculate the confidence interval. I just want to show you how to do it manually so that you know how to do it going forward. So looking at your problem, as you see here, we have all this information up here, but when I boiled it down in my response, these are the important things. So we have x equals 6750, and remember, that's the number of successes, n equals 15,000, and your confidence level is 95%. So I went down here and I saw that you used quite a few of these numbers to find the upper and lower limits, and you have n equals. I'm not quite sure where you got the formulas from, but I want to make sure it's really clear what we need to do. So from the lesson this week, we know that we have p hat minus that big section of the thing, that's z alpha over 2, times all under the square root p hat times 1 minus p hat all over n. Remember, p hat is our sample proportion. That's our x divided by n. So let's first look at that. So we've got p hat, let's look over here, p hat equals x over n. And what we just said right here, if we scroll back up, x is equal to 6750. So we have 6750 over 15,000. So when we put that into the calculator, we get 0.45. So our p hat is 0.45. Now going back again to our formulas here, we need to find this z alpha over 2 and p hat times 1 minus p hat over square root of n. So from the lesson this week, we also, and I think you found it down below in your calculations. Let me check real quick. Maybe not. Excuse me. So from the standard normal distribution table, which is what we use for the population proportion, we know, and it's at the very bottom of the table, that the critical value z alpha over 2 for 95% is 1.96. In this case, 96, and this is for 95% confidence level. If you have any questions about how to find that, let me know. But basically, you need to go into the table and find the closest value to 0.025. The reason for that is that we're at 95% confidence. So that means that if you solve this for 95 and you have alpha over 2, it's going to be 0.025. If you have any questions about how to find that, let me know. But at the very bottom of that distribution table, there's a little smaller table for confidence interval critical values for very common levels of confidence. So 90%, 95, 98, and 99. In there, it says 1.96 for 95%. So now we have everything in here we need. So let's look at our lower bound. So lower is going to equal p hat minus z alpha over 2 times the square root p hat 1 minus p hat all over n, and that's all under the square root. So that's going to equal, we have 0.45 minus 1.96, and then we have 0.45 times 0.55 all over 15,000, and that's all under the square root. Now, when I put that into the calculator, I get 0.442038. That's for the lower bound. Now let's go for the upper bound. It's going to be very similar. We're going to have p hat now plus z alpha over 2. Now we have p hat 1 minus p hat all over n, all under the square root. Now, when you're doing these by hand, one of the things that's really helpful is to just calculate this part right here, because then you can just add and subtract it. You don't have to redo this every time. I'm just walking this through because I want to make sure it's really clear. So we have 0.45 plus 1.96, and we have 0.45 times 0.55 over 15,000, all under that square root. And when I put that into the calculator, I get 0.457,962. So then we have our lower bound is that 0.44 2 if we have to round to the third decimal, and then our upper would be 0.458 if we round. Now, a much easier way to do this, if you're having a hard time calculating it, would be to do it in StatCrunch. So let me go ahead and bring that window up just to show you how to do that in StatCrunch. So I'm going to bring it right over here just so we've got our numbers handy. Right there. All right, so here we're going to go to Stat, Proportion Stats, one sample with summary. We don't have a data set, we just have the summary data. And then all you just put in your number of successes, which is 6750. Number of your number of observations, 15,000. And then come check confidence interval. It's already set to 95, but let's say you had a 99, you would just change that to 99. We're going to leave that at 95 and click compute. Now, if you'll see here, our upper level, our upper limit matches. See how it's 0.45796, blah, blah, blah. It's very similar and it's rounded from what we see over here. So now let's go to our other page and look at our lower limit. Here we have 0.442 and here we have 0.442. So you see it's very close. So that's how you would compute it manually and how you can do it in StatCrunch. So if you have any questions about that, let me know.